Hello, this is Sal. In today's practice lab, I will create a small network. I'll connect the network devices and configure those devices to support IP version 4 connectivity, LAN redundancy, and link aggregation. I will then configure EIGRP for IP version 4 on the network and verify connectivity and HSRP. On the description of this video, you will find two files. One for the packet tracer source files and the documents to walk you through the lab step by step until you finally will be able to verify the configurations you did during this lab. I hope my videos are helpful for those who are seeking to be certified for the Cisco exams. If you like my videos, please subscribe to my channel and share the video on your Facebook page and give me the thumb up. And please let me know if you have any suggestions, comments, or questions. I will gladly answer you back. We have in this network here, we have router 1, router 2, and router 3 are connected with the serial links here. On router 1, we have the three loop backs 1, 2, and 3. And on router 2, we have loopback 0, which represent here on this example or this lab the internet. We have router 3 is we have three loopbacks connected to router 3. And here we have three switches, switch 1, switch 2, and switch 3. And we have the connected via trunks, two trunks between the switches. Now, nothing is configured yet on this network, on this topology network here. I'll start doing the configurations with router 1 here. First, I will configure terminal, the host name, router 1. Now I will disable DNS lookup. Simply type no IP domain lookup. Enter. Now I will encrypt the privilege exec password, which is CCNA, enable, secret, CCNA. Now I will configure the console access line console 0. As for the password, it's Cisco in this example for login. And also I will configure telnet access password of Cisco. Now the lines, VTY lines from 0 to 4, just 5 lines. And the password also is Cisco in this example and for the login. Next, I will encrypt the plain text password. Simply type service, it's within the service. Password encryption. And I showed you how we do this here with router 1. Just do it on your own for router 2 and router 3, just to have, to know how to do it on your own. Now I will configure the interfaces on the router and activate them. Now we have the interface on the gig 01, the IP address of 172.16.0.1 with /24 subnet mask, and activate with no shut. The other interface on the serial 000, it's with the IP address of 10.1.1.1 with /30 subnet mask of 255.255.255.252. Activate the port or open it or enable it with the no shut command. Next, I will configure the loopback interfaces on the router. As you can see, we have three loopback here on router 1, 2, and 3. So as for the loopback 1, and you don't need to activate it or enable it. When you enter on the loopback, it will be automatically done for you. And this is on the IP address of 172.16.0.1 10.1.1 with /24 subnet mask, and the other loopback 2 with the IP address of 172.16.2.1 with /24 subnet mask, and the other loopback of the loopback 3, and this also with the IP address of 172.16.3.1 /24 subnet mask. Now, next, I will do the configuration I did here on router 2. Enable, configure terminal. The host name here is router 2. Now I'll configure the interfaces on the router and activate them. We have two interfaces. Here, the serial links on serial 000 and the serial 001. Now, the first one of serial 000, this is with the IP address of 10.1.1.2 with /30 subnet mask, and activate it with the no shut. And on the other interface of serial 001, that's with the IP address of 10.2.2.1 /30 subnet mask, and activate it with no shut. Next, I will configure the loopback 0 on the router, which simulating the internet. Interface loopback 0, and this is with the IP address of 209.165.200.225 and with /29 subnet mask of 255.255.255.248. Next, I will configure a default route, out loopback 0. I'll exit from here, IP route to any network with this subnet mask, and to route out loop back 0. Enter. Next, I will do the configuration on router 3. Enable, configure terminal, host name of router 3. Now, on the interface of gig 01 with the IP address of 172.16.0.3 with /24 subnet mask, and activate it with no shut. The other interface on serial 001, that's with the IP address of 10.2.2.2 with /30 subnet mask. No shut. Now, I will configure the loopback interfaces on router 3. Now, as for interface loopback 4 with the IP address of 172.16.4.1/24 subnet mask, and loopback 5 with the IP address of 172.16.5.1/24 subnet mask, and loopback 6. That's with the IP address of 172.16.6.1/24 subnet mask. Next, I will do the configurations on the switch, starting with the switch 1 here. Enable, configure terminal, host name, SW1, I will assign the IP address to the default SBI VLAN 1. Now enter VLAN 1 on switch 1, and this is with the IP address of 172.16.0.11 with the /24 subnet mask, and activate this VLAN with no shut. Now the default gateway for this switch of 172.16.0.2. This is the virtual gateway. Later on this lab, I'll explain why. Next, I will configure the trunking on the interfaces connected to the switch 2 and switch 3. And I will use VLAN 1 as the native VLAN. Here on switch 1, we have these interfaces, or these links here, F0, 3, 4, 1, and 2. They are connected to the switches here. And we have the port here, F06, is connecting to PCA. So on switch 1, the range of the interfaces here of F0, 1 to 4, this we will, interface range F0, 1 to 4, these are our trunks connecting to switch 2 and switch 3. Switch port mode trunk, switch port trunk native VLAN 1. Enter. Next, I will disable the dynamic trunking protocol DTP on all other ports. I will make sure the ports are configured as access ports and then shut down the unused ports. So here I will configure them by a range, not individually, as groups. Interface range from port 0, the port from 5 to 24, because we have the first 4 as trunks, and gig 0, 1, and 2. Enter. Switch port mode access, switch port no negotiate. Now the range of the port of F0, 7 to 24, from 7 to 24, and 1 and 2, gig 0, 1, and 2. Sorry, I put 27, this is supposed to be 24. Enter. These are unused ports. Here, as you can see, we have 1, 2, 3, 4. We are using these ports, and the 2 gigabit Ethernet on the switch, we are not using them. We are using 1, 2, 3, 4, 5, and 6. 5 is connected to the router 1, but now from 7 until 24, and the 2 gigabit Ethernet 0, 1, and 2 are unused. Here we can simply type shut. We shut them down for security reasons. I'll do next the configuration on switch 2. I'll do the same. I want you to do it on your own, but let's do it together, and then you do it on your own when you download the packet tracers files. Enable configure terminal host name for switch 2. We will give it the name of SW2. I will assign the IP address for the default SBI VLAN 1 on the switch. So here we have VLAN 1 with the IP address of on switch 2 of 172.16.0.12 with /24 subnet mask. Activate the port with the no shut. Now the default gateway of 172.16.0.2. Now I will configure trunking on the interfaces connected to switch 1 and switch 3. And I will use VLAN 1, just the same how we use it with switch 1. I'll use VLAN 1 as the native VLAN. So here on switch 2, we have, can I shrink this a little? I can't. Here we have the ports 1, 2, 3, 4. This is what we will configure as trunk connected to switch 1 and to switch 2. So here interface range of bus 0, 1 to 4, switch port mode trunk, switch port trunk native VLAN 1. Next, I will disable the dynamic trunking protocol DDP on all other ports. I will make sure the ports are configured as access ports and then shut down the unused ports. Here we have the range of ports of from bus 05, F02, 24, and gig 0, 1, and 2. Switch port mode access, switch port no negotiate. Now we have the range of addresses from 5 to 17 because we have port 18 is connecting here the PCB on port F018. So interface range F05 to 17, and now from F019 to 24 and gig 0, 1, and 2. Those are the ports we are not using, but from port 1 to 4 we are using them to as trunk with the other switches, and we have port 18. Here we are using it to connect PCB, and of course the 2 gigabit Ethernet 1 and 2 we are unused. Simply type here shut. Now I will do the configuration on switch 3. Enable, configure terminal, host name, SW3. I will assign the IP address now to the default SVI, VLAN 1. So enter VLAN 1 with the IP address of 172.16.0.13 with /24 subnet mask, and activate this VLAN with a no shut. Now for the default gateway of 172.16.0.2, enter. Once again here I will configure a trunking on the interfaces connected to the switch 1 and switch 3. To switch 2 and 1 and 2. And I will use VLAN 1 as a native VLAN. So the range of addresses here from 1 to 4, they are connected to switch 2 and switch 1. Enter. Switch port mode trunk, switch port trunk native VLAN 1. Next, I will disable the DTP on all other ports. I will make sure that ports are configured as access ports and then shut down the unused ports for security reasons. Here the range of addresses from 5 to 24 and gig 0, 1, and 2, switch port mode access, switch port no negotiate. Now the range of addresses or the port from 6 to 17, because 18 we are using it to connect the PCC to the switch, and 19 to 24, and the 2 gig 0, 1, and 2, these are the unused ports, and we want to shut them down. Next, I will configure LAN redundancy and link aggregation. I will start by configuring spanning tree mode as rapid PBST on switch 1. So back to switch 1 here. Exit. Spanning tree. The mode is rapid PBST. I will configure VLAN 1 as primary route bridge. Spanning tree. VLAN 1. This is the root primary. And then hit enter. Now I will configure the interface connecting PCA with port fast and BPDU guard. Interface is F06, spanning E, spanning tree, port fast, spanning tree, BPDU guard, and we want to enable this. Now on switch 2, I'll do the same. Here, spanning the mode is rapid PBST, and I will configure port fast and BPDU guard on the interface connecting to PCB, which is on port F018. Spanning tree, port fast, spanning tree, BPDU, and enable. Going to switch 3. Spanning tree mode rapid PBST, and I will configure VLAN 1 as primary secondary route bridge on switch 3 because we have switch 1 as a primary. Spanning 3 on VLAN 1, the route VLAN 1, sorry, route secondary. Enter. Now I will configure the F018, which is connecting PCC to the switch interface F018. Spanning tree port fast, spanning tree BPDU guard enable. Now I will configure HSRP on router 1. The password of Cisco, enable, and this is CCNA, configure terminal. Here, I will configure the HSRP virtual IP address on the port of gig 01 on router 1. And the virtual IP here is 172.16.0.2 in group 1. Here, if you notice, when I was configuring the default gateway on the switches, I use this virtual IP address. And even for the PCs here, the configuration, I pre-configured them with the virtual IP address. As for this PCA, this is its of 172.16.0.1, but I, just did it to be 0.2, which is the virtual IP address for this example when we configure the HSRP. So now on back to router 1, configure terminal. Now on the interface of gig 01, standby group number 1 with the IP of 172.16.0.2. Enter. Now I will make router 1 as a primary for the HSRP router. Standby group 1 priority of 150. Here priority of 150. The default is 100 priority, but we are giving router 1 the priority of 150. I will do the configuration here so router 1 becomes the primary HSRP router on a reboot. Now, standby group 1 preempt. Enter. Next, I will configure HSRP on router 3. I did this here. I will do this on router 3. Enable, configure terminal. On the interface of gig 01, standby group 1 and with the IP of 172.16.0.2. Enter. Sorry, there is group 1 IP of this IP of 172.16.0.2. Next, I will configure LACP ether channel between switch 1 and switch 3. I configure it here as I highlighted it. On switch 1, I will configure an LACP ether channel on the interface connected to switch 3. I will use channel group 1 and enable LACP unconditionally. On switch 1, interface range from because we have these two ports here connected, F03 and F04, 3 and 4. Enter. Channel group 1 mode active. Enter. Now on switch 3, I will configure an LACP ether channel on interface connected to switch 1. I will use the group channel 1 and enable LACP only if LACP device is detected. Here we did it unconditionally, but here only if an LACP device is detected. And this is how the command goes on switch 3. We have two ports connected to switch 1 of F03 and 4. Enter. Channel group 1 mode is passive. Enter. I did configure EtherChannel here between switch 1 and switch 3. Next, I will configure EIGRP for IP version 4 dynamic routing protocol. I will configure EIGRP on router 1. Back here to router 1. Exit. The autonomous system 1 router EIGRP 1. The router ID of 1.1.1.1 EIGRP router ID 1.1.1.1. I will advertise directly connected networks and use a classless network address. So here on router 1, we have the network of 10.1.1.0 connected to router 2, and we have the 3 loops, loopbacks, and we have this interface on gig 0, 1. So the command goes like this: the network of 10.1.1.0 0003. Enter. And the other network of 172.16.0.0 with the inverse subnet mask of 0.0.0.255. The other network of 172.16.2.0, and the third one is the 3.0. And the network of 172.16.0.0, the one on the gig 01. Enter. Next, I will set all LAN interfaces as passive. Passive interface on the gig 00 and loopback 1. And loopback 2 and loopback 3. Enter. Next, I will manually disable automatic summarization, simply with the command no auto summary. Next, I will apply a manual summary route for the loopback interface networks. Here we have the 3 loops of the first one of 172.16.1.0/24, the second loop back of 2.0/24, the third loop back of 3.0/24. So here, to summarize all of them, we will come to 172.16.0.0/22 with the IP address of 172.16.0.0/22. So here on the interface of serial 000, the one connected to router 2, an IP summary address for the EIGRP with autonomous system 1 with the summarized IP address of 172.16.0.0 with /22 255.255.252.0. Enter. Next, I will set the bandwidth on the interface of 000 to 128 kilobit per second. Bandwidth, we are still on the interface of 000. bandwidth of, simply type 128, enter. Next, I will change the hello interval on the interface of serial 000 to 30 seconds. We are still on the interface. Now, the command simply type IP hello interval for EIGRP Autonomous System 1. We have the options up to 65535. Now I can type 30 here and hit enter. We change the hello intervals. But now when I want to change the hold time on the same interface to 90 seconds, because if you configure this to 30, the hold time is 3 times. Now the default for the hello interval is 5, and 3 times the 5 is 15. But now we have it, the hello intervals is 30. The hold time, 3 times 30 is 90. Unfortunately, with packet tracer, it doesn't take only just to change the hello intervals. But now if I type IP hold time EIGRP 1, try to change it to 90 and hit enter, it won't take it. That packet tracer doesn't support this command, and also to the bandwidth percentage, also it won't take it. So I need to change this back to the hello intervals to 5. So with the up arrow, I will go here and simply type no and hit enter, because I cannot change the other one to be 3 times the hello intervals for the whole time. I'm sorry about that. Packet tracer doesn't support these commands because the default route, the default value for hello interval is 5 seconds, and the default value for hold time is 3 times the hello interval, which is 15. Now, if we can set the hello interval to 30 seconds and cannot set the hold time to 90 seconds, the hello interval, which is 30 seconds, will be higher than the hold time, which is 15, and this will cause the EIGRP link to fail. And even trying to change the bandwidth percentage, we want to change it to 70. If I type the command IP bandwidth percentage EIGRP 1 to 70%, it won't do it because packet tracer doesn't support it. So this is how you can configure the commands, if you use a different software, but with packet tracer, it doesn't support these commands. Only we can change the hello interval. Sorry about that. Next, I will configure a keychain named EIGRP key with 1 key string and the key string of Cisco. So I'll exit from here. As we said, keychain EIGRP dash key, all caps. Key 1 and the key string of Cisco. N. I will configure MD5 authentication on the interface of serial 00 using the key chain, which we configured already. Here, configure terminal on the interface of serial 000 IP authentication mode EIGRP 1 MD5. Enter. IP authentication keychain for the EIGRP autonomous system 1 EIGRP-key. Enter. I will do the configuration on router 2. We did this on router 1. So on router 2, enable, configure terminal, router EIGRP1, the router ID of 2.2.2.2. Now I will advertise directly connected networks and use classless network addresses. So here we have two networks. The network of 10.1.1.0 connected to router 1 with the inverse subnet mask of this, and the other network of 10.2.2.0 with the inverse subnet mask of this. Next, I will automatically disable automatic summarization. Simply type no auto summary. And then I will propagate the default route to all other EIGRP routers. Simply type the command redistribute static. Enter. Next, I will set the bandwidth on both serial interfaces to 128 kilobit per second. So on the interface of serial 000, bandwidth 128, and the other interface of serial 001, the bandwidth also of 128. Enter. Next, I will configure a keychain named EIGRP key with one key string and the key string of Cisco. Key chain EIGRP dash key. Key 1 and the key string of Cisco, the same as we configured on router 1. I will configure MD5 authentication on serial interfaces using the keychain we configured. Exit. And exit from here. On the interface of serial 000, IP authentication mode EIGRP 1 MD5. IP authentication keychain for the EIGRP autonomous system 1 EIGRP dash key. Enter. So I'm done here on router 2 configuring EIGRP and with router 1. So now we will move to router 3. Enable, configure terminal. I will configure EIGRP on router 3 with autonomous system 1 and the router ID 3.3.3.3. Router EIGRP with the autonomous system number 1, the router ID of 3.3.3.3. Now I will advertise directly connected networks. I will use the classless network addresses using the IP address of network. So we have here network 10.2.2.0 with the inverse subnet mask of this, and network 172.16.0.0 with the inverse subnet mask, and the network of 172.16.4.0 with the inverse subnet mask of 0.0.0.255, and the other network on loopback 5 and loopback 6. And we did, yeah. Next, I will set all LAN interfaces as passive. So passive interface on the gig 01 and passive interface on loopback 4 and 5 and loopback 6. Enter. I will manually disable automatic summarization. Simply type this command, no auto summary. Bandwidth. On the serial interface 001. Bandwidth 128. Now it's off. Next, I will apply a manual summary route for the loopback interface networks. We have 3 loopbacks, 172.16.4.0/24 and 5.02/24 and 6.0/24. And when we summarize these 3 IP addresses, we will come up with 172.16.4.0/22. So here we are still on the interface of serial 001. IP summary address for the EIGRP or the autonomous system 1 of 172.16.0 .4.0/22 of 255.255.252.0. Enter. Next, I will configure a keychain named EIGRP, just like we configured on the other routers, with one key string Cisco. Key chain EIGRP dash key, the key 1, and key string of Cisco. Next, I will configure MD5 authentication on serial 001 using the keychain 1 configured earlier. So now, on the interface of serial 001, IP authentication keychain mode EIGRP keychain EIGRP, sorry, no more. 1 MD5. The name of the IP authentication, key chain EIGRP 1 EIGRP key. IP. Okay. Next, I will verify network connectivity. I will verify that EIGRP is functioning as planned. Now, what command will display all connected EIGRP routers? What command will display all connected EIGRP routers? So on router 1, I will run this command, Cisco enable CCNA, and the command is show IP EIGRP neighbor. So on router 1, we have router 2, which is its neighbor. The next question, what command display EIGRP hello interval, hold time, bandwidth percentage, and authentication mode for all EIGRP interfaces on the router? What command display EIGRP hello interval, hold time, bandwidth percentage, and authentication mode for all EIGRP interfaces on a router? The command is show IP EIGRP interface detail. But unfortunately, it's not supported by packet tracer. But this is how to run the command. If you want to display the hello interval, the hold time, the bandwidth percentage, and the authentication mode for all EIGRP interfaces. Now, what command displays the EIGRP autonomous system number, router ID, address summarization, routing networks, and passive interface configured on a router? The command is show IP protocols. Here it will show you everything you need. The protocol we are using is EIGRP with autonomous system 1 and the router ID and the path for the minimum. This is the auto summarization, automatic class summarization, the networks. This is the command that you use, which is show IP protocols. Now, what command displays only EIGRP routers? Simply type the command show IP route EIGRP, and it will show you only EIGRP. Now I will verify end-to-end connectivity. I ping from PCA to PCC. From PCA here, ping PCC. Ping 172.16.0.23. and ping from PCB to PCA. Ping 172.16.0.21, and it is successful. And now we will ping from PCB to PCC. We are on PCB. We want to ping this guy here. Ping 172.16.0.23. And now I want to ping from PCB to the loopback 0, which is the internet on router 2. We are still on PCB. Ping 209.165.200.225. And it was successful. And I want to trace route from PCB to the loopback 0. Trace RT 209.165.200.225. Enter. And as you can see, everything was successful. Now, this is how to do the configuration. I hope you learned something from this video. If you download the packet tracer source files, you will be able to even run the show run commands. I don't want this video to take lots of time that you will be bored with it, but when you download the packet tracer, just keep doing it over and over again. Get familiar with or used to the commands, the show commands, how to do the configuration. Sorry about that, not all the commands are supported by packet tracer. Thank you so much for watching. Please, if you like this video, subscribe to my channel and share this video on your Facebook page and tell your friends about it. And if you have any suggestions, please write me. I'll see you soon in my next video. Thank you so much. Have a nice day.